Ring planet life on Mars. For decades, we have searched for life in the cosmos, but we may have been looking in the wrong way. A new discovery on Mars suggests the most profound secrets are not in distant signals, but in the ground beneath our rovers. The question is no longer just if we are alone, but if we have been overlooking evidence right next door. The Sapphire Canyon find. The entire controversy centers on a single sample named Sapphire Canyon. This object is being analyzed not as a random piece of geology, but as a potential technological artifact. If confirmed, it will be the first concrete evidence of a biological process beyond Earth. What exactly did the Perseverance rover uncover in the Jezero crater? The Perseverance rover was analyzing terrain in the Jezero crater, an area known to be a former lake bed. It identified a rock whose chemical and structural data did not match the surrounding geology. The anomaly was so significant that it was flagged as a top priority target for further analysis. The report mentions a sample named Sapphire Canyon. What makes this particular piece of rock so special? All previous data from Mars has shown patterns consistent with known geological or chemical processes. The Sapphire Canyon sample is an exception because it contains microstructures that are ordered and complex in a way that current models cannot explain. This is a direct challenge to our understanding of natural formation on Mars. What are these leopard spots and poppy seed structures found in the rock? The rock contains repeating, non-random patterns referred to as leopard spots and poppy seed structures. These are microscopic, spherical, and granular inclusions that are distributed in a regulated, almost organized way. Such a high degree of structural order is not expected from chaotic geological events. The discovery of organic molecules like decan and undecan was highlighted. Why is this a big deal? The analysis detected long-chain hydrocarbons, specifically decan and undecan. These are complex organic molecules that are known to be durable byproducts of biological decay processes on Earth. Their presence in an ancient Martian rock suggests a source that is either an unknown geological process or preserved biology. What are vivianite and gragite, and why do they matter? The minerals vivianite and gragite were found together within the sample. On Earth, this specific mineral combination is a strong indicator of anaerobic microbial ecosystems, as they are direct byproducts of their metabolic processes. Finding them on Mars points to a specific and potentially biological chemical pathway. The scientific interpretation. The current challenge is to distinguish between an unprecedented biological discovery and an unknown, complex geological phenomenon. The data contains multiple lines of evidence that point towards a biological origin. However, the core of the scientific process is to now try and falsify that hypothesis with non-biological explanations. What does it mean to find a potential biosignature? A potential biosignature is an observation that is consistent with life, but is not yet definitive proof of it. It can be a chemical, a structure, or a pattern that is difficult to explain without a biological origin. The current findings are a collection of several such signatures, which strengthens the case, but does not yet close it. How do these findings change our understanding of Mars's ancient climate? This evidence requires us to update our models of Mars's history. The data supports a past where the planet had a denser atmosphere and stable liquid water on its surface for extended periods. This moves the planet from being theoretically habitable to a world with confirmed life-sustaining conditions. Could these organic molecules have survived for billions of years on Mars? The discovery of intact organic molecules billions of years old is a critical finding in itself. It demonstrates that the Martian environment, specifically within certain mineral matrices, can preserve complex chemicals despite intense surface radiation. This proves that the evidence of past life, if it existed, can still be found today. The mineral siderite was also found. What clue does it provide about Mars's past? The presence of siderite, an iron carbonate, confirms that the atmosphere was once rich in carbon dioxide and interacted with surface water. This mineral acts as a historical record of the planet's atmospheric pressure and composition. It provides a concrete data point for a past climate that was much more Earth-like than it is today. How do these discoveries fit together to build a case for past life? Scientists are now correlating these independent data points: the ordered structures, the specific minerals, and the complex organic molecules. Each clue on its own could be dismissed, but their presence together in a single sample suggests a unified underlying process. The next step is to determine if that process was geological or biological. So, are we looking at a smoking gun or just more tantalizing clues? We do not have a smoking gun. We have a collection of highly correlated, anomalous data points that are difficult to explain. The hypothesis of ancient microbial life is the most straightforward explanation, but it is not yet proven. The evidence is compelling, but it remains circumstantial until tested on Earth. The unanswered questions. Now, we must address the significant scientific skepticism surrounding these findings. Every piece of evidence is being rigorously challenged by experts searching for non-biological explanations. The high standard of proof requires that every alternative hypothesis must be systematically ruled out. What are the leading non-biological explanations for these findings? Many complex structures in nature appear lifelike, but are not, such as the formation of crystals or snowflakes. These are the results of simple physical laws, not complex biological processes. The core of the debate is whether the Martian structures are just another example of complex abiotic chemistry. Why can't we be certain about life on Mars without bringing samples back to Earth? The rover's instruments provide excellent preliminary data, but they have limitations. They cannot perform the destructive, high-fidelity tests needed to confirm the origin of these structures. For definitive proof, the sample must be analyzed in a terrestrial lab using more advanced instrumentation. What are the biggest technical and logistical hurdles for a Mars sample return mission? The Mars sample return mission is a multi-stage engineering challenge with an extremely high risk of failure. It involves launching a rocket from another planet and having a separate spacecraft capture the payload in orbit. The complexity and cost are immense, justified only by the unprecedented scientific value of the samples. If life did exist, what might have caused it to disappear? If life existed, its extinction was likely caused by catastrophic atmospheric loss. The planet's magnetic field collapsed, allowing the solar wind to strip away the atmosphere over millions of years. This would have caused the surface water to boil away or freeze, leading to a global sterilization event. How do scientists ensure that samples from Mars are not contaminated by Earth life? Planetary protection is a two-way quarantine protocol with strict, non-negotiable rules. The first objective is to prevent contamination of the Martian samples with any microbes from Earth. The second is to ensure that any potential Martian biomatter is completely isolated to prevent a terrestrial contamination event. What happens if a returned sample does contain something that could be harmful? A returned sample was the next major step in the search for Martian life. The next phase of exploration will focus on subsurface analysis. Future missions are being designed with deep drilling equipment to access rock layers shielded from surface radiation. The search is moving underground, where the environment is more stable and the chances of preservation are higher. Public reaction and conspiracy. The announcement has become a case study in the sociology of science. The public reaction has been split between uncritical acceptance and automatic dismissal. The nuanced, uncertain position of the actual scientists is often lost in the polarized public debate. How did the public and social media react to the announcement? The initial announcement led to an information cascade on social media. The carefully worded scientific statements were immediately simplified into definitive and often incorrect headlines. This process demonstrates how scientific uncertainty is often the first casualty in the modern media environment. Why do complex scientific findings often get simplified into misleading headlines? The process of information decay occurs when complex topics are communicated to a mass audience. Nuance is lost at each step as the story is retold to maximize engagement. The result is that the final, most shared version of the story is often the least accurate. A common theory is that NASA timed this announcement to distract from other issues. What is the counterargument? The timeline for a major scientific publication is measured in years, not news cycles. A paper undergoes a lengthy, anonymous peer review process that is completely disconnected from political events. The suggestion that its timing is a political tactic is inconsistent with how the scientific publication process actually works. How do scientists respond to the claim that the samples are just contaminated? To counter the claim of contamination, the mission uses witness tubes. These are control samples that are exposed to the rover's environment to collect any potential terrestrial contaminants. This provides a baseline that allows scientists to differentiate between contamination and a genuine Martian signal. What about the idea that this is all just a visual illusion or pareidolia? Pareidolia is a known psychological phenomenon where the brain imposes familiar patterns on random data. The scientific method, however, is a system designed to remove that bias through objective, repeatable measurements. The current analysis relies on multi-instrument data, not just visual interpretation. Let's talk about the more extreme narrative, the alien cover-up. What are its common forms? The narrative of an alien cover-up typically involves three elements: a secret discovery, a powerful agency suppressing it, and a whistleblower revealing the truth. These stories are compelling because they offer a simple, dramatic explanation for complex events. However, they rarely provide verifiable evidence to support their claims. Why are theories about NASA editing photos or hiding structures so persistent? The belief in secret knowledge is often more psychologically appealing than accepting a complex, uncertain reality. A conspiracy theory provides a clear, simple narrative with good and evil actors. This is often more satisfying than the messy, incremental, and often ambiguous process of scientific discovery. How do scientists differentiate between a genuine anomaly and a conspiracy theory? The scientific method is a process designed to invalidate hypotheses. It subjects every claim to rigorous testing and demands that the evidence be independently verifiable. A theory that relies on untestable claims of secrecy or suppression cannot survive this process of falsification. What is the danger of letting speculation and misinformation dominate the conversation? The history of the canals on Mars is a powerful cautionary tale. A prominent astronomer, Percival Lowell, claimed to see evidence of a global irrigation system, which was later proven to be an optical illusion. This demonstrates how a compelling but incorrect idea can misdirect scientific resources for decades. How can the public engage with this news in a healthy and critical way? A non-expert can best evaluate scientific news by focusing on the process, not the conclusion. Look for whether the findings have been peer-reviewed, whether the data is public, and whether other experts in the field agree with the interpretation. A healthy skepticism of sensational headlines is the most reliable critical thinking tool. What is the one question people should ask themselves before sharing a sensational claim about Mars? Before sharing a sensational claim, one should ask a simple question. Is this information falsifiable? A real scientific claim comes with a set of conditions under which it could be proven wrong. A conspiracy theory, on the other hand, is often structured in a way that it can never be disproven. What is pareidolia, and how does it relate to seeing things in Mars photos? Pareidolia is a cognitive shortcut, a glitch in our pattern recognition system. The brain is optimized for quickly identifying familiar objects, especially faces, and will often create a false positive from random stimuli. It is a documented bias that must be actively filtered out during scientific image analysis. Why is the idea of an alien cover-up so compelling to so many people? The narrative of a cover-up is psychologically powerful because it reframes the unknown as a secret. A secret implies there is something concrete to be known, which is more comforting than the idea that we simply do not have the answer. It replaces ambiguity with a story of power and deception. How does the international nature of space exploration serve as a check against secrecy? The structure of modern space exploration, with its many international partners and public data archives, makes a long-term cover-up logistically unfeasible. Data from NASA missions is analyzed by independent researchers and agencies around the world. Any attempt to systematically hide a major discovery would likely be exposed very quickly. What is the real story behind the so-called face on Mars? The face on Mars was the result of a low-resolution image and a specific sun angle that created an illusion. Higher-resolution images taken years later with better technology showed a normal geological formation. It serves as a classic example of how incomplete data can lead to incorrect but compelling conclusions. If we did find definitive evidence of past microbial life, what would that truly mean for humanity? Confirming past microbial life on Mars would fundamentally change our understanding of biology. It would establish that life is not a unique miracle of Earth, but a fundamental property of the universe that can emerge on any suitable world. It would mean the cosmos is filled with biology, and we're just one expression of it. How do you personally feel when you see these images and data from Mars? The data from this rock produces a feeling of profound cognitive dissonance. The observations are not easily explained by known science, and they point to conclusions that could be revolutionary. It is the feeling of standing at the edge of a great unknown, holding a piece of data that should not exist. What is the most misunderstood aspect of the search for extraterrestrial life? The most significant misunderstanding in the search for life is the assumption that it will look like us. The true search is for any process that creates a sustained, local reduction in entropy funded by an external energy source. By that definition, life could take forms we are not yet equipped to recognize.